Hi, my name is Alex Fleischman, and welcome to the video overview of the third kinematics equation demonstration. Let's start with the problem. 5 students are trying to figure out the initial velocity of a popper. The teacher has only provided them with a popper and a meter stick. How can the students figure out the initial velocity of the popper? Create a method for solving this problem. The method can be either qualitative or quantitative. So how can we approach this problem? Let's start with a simple algebraic derivation. If a popper is not accelerating, how does the initial magnitude of the velocity relate to the final magnitude of velocity? Well, we could state that the final magnitude of velocity is equal to the initial magnitude of velocity. Therefore, the final velocity squared is equal to the initial velocity squared. Well, let's look at the units of our equation. They're in meters squared per second squared. So if the popper is accelerating over a distance delta y, how could we relate acceleration in terms of meters squared per second squared? Well, we could state that meters squared per second squared is equal to 2 times the acceleration times delta y. This is because meters per second squared times meters gives us meters squared per second squared. Note, the 2 in front of the a delta y can be explained using an algebraic derivation. This can be seen on the next slide or in the Smart Notebook presentation. Let's continue. If the popper is released with an initial velocity v initial and accelerating with a magnitude a over a distance delta y, how can we calculate the final velocity of the popper? Well, we could state that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration of the object times the change in distance. Note, this equation is known as the third kinematics equation. Let's return back to the original problem. Students can use a meter stick to measure the maximum height of the popper, delta y. We can also state that the final velocity of the popper at its maximum height is 0 meters per second. Also, the popper is in free fall. Therefore, the acceleration of the popper is equal to the acceleration due to gravity. So a is equal to negative 9.8 meters per second squared, which is equal to g. From this information, we can calculate the initial velocity of the popper, v initial. Let's work through our equation now. Using the third kinematics equation and the information given, the final velocity is 0 meters per second. So 0 is equal to v initial squared plus 2g delta y. G is the acceleration due to gravity, which is negative 9.8. So we can move that side of the equation to the other side of the equal sign, and we get that the initial velocity squared is equal to 2 times 9.8 times delta y. Now we could just take the square root and get that the initial velocity is the square root of 2 times 9.8 times delta y.